Hello, welcome back. We are now on chapter 7, rational exponents, radicals and complex numbers. And today we will work on section 7.1, radicals and radical functions. First objective, find square roots. The opposite of squaring a number is taking the square root of a number. The number b is the square root of a if b squared equals to a. And that means if b squared equals to a, square root of a equals to b. And the principal square root of a non-negative number a is its non-negative square root. The principal square root is written as this, square root of a. The negative square root of a is written as negative square root of a, like that. So this, the result of this is always going to be a non-negative number. That means it's equals to 0, or a positive number. Okay? Non-negative means this is going to be equals to 0 or a positive number. Find each square root, and well, you can calculate this by hand, or you can use your calculator. I don't mind. Square root of 49 is going to be equals to 7. And square root of 25 over 16, you can write as the square root of 25 over square root of 16. And this is going to be equal. Here on the numerator is 5, and on the denominator is 4. Negative square root of 4. So the negative is outside the square root. See, in front of the square root. That means negative, and the square root of 4 is 2. Square root of 0.81. This can be rewritten as 81 over 100, right? Square root of 81 over 100, which is the same thing as square root of 81 over square root of 100, which is 9 over 10, or 0.9. Okay, now letter E. Letter E up here. Square root of 9 times x to exponent 10. We can write this as square root of 9 times square root of x exponent 10, which is equal to 3 times x exponent 5. Letter F, negative square root of 25. And notice that the negative sign is in front of the square root, is outside the square root in front, right? So it's negative 5. And this letter G, pay attention, big difference. Big difference because the negative sign is inside the square root. Negative sign is inside the square root, and this has no solution, no real number. No real number. Okay? The square root of a negative, any negative number, is not a real number. This objective now is about approximating roots, and actually it's quite simple. If the question asks you to approximate square root of 5, and then it's going to say to 3 decimals, and always usually the question say how many decimals it's needed. So we're gonna approximate the square root of 5 is this number that goes on, is an irrational number, and we're gonna approximate as square root of 5 approximately equal to 2.236 with 3 decimals. And now objective 3, find cube roots. And cube roots, if you have a real number a, if b cubed equals a, that means a cube root of a equals b. And in this situation, for cube roots, or the root, when you have the index as an odd number, like here, the cube root, there is no restriction. The a can be a negative number, actually, can be a negative number, and you can find the cube root of negative numbers. Let's check some examples, and again, you can calculate this by hand, or you can just use your calculator. Square root of 27, square root, no, it's cube root. Now we're working cube root. Cube root of 27 is 3, right? 3 times 3, 9, times 3, 27. Cube root of negative 125. Now, as I mentioned, you can have a cube root of negative numbers. It's going to be negative 5, because negative 5 times negative 5 is positive 25. But if you multiply again by negative 5, equals to negative 125, right? And cube root of the fraction 8 over 125 is cube root of 8 over cube root of 125. And cube root of 8 is 2. Cube root of 125 is 5. We still have here cube root of negative 8 times x exponent 9. And we can write this as cube root of negative 8 times cube root of x exponent 9, which is equal cube root of 8 negative 2, negative 8, cube root of negative 8, negative 2, and cube root of x exponent 9 is x, 9 divided by 3, 9 divided by 3, which is 3. Very good. Now we are working on objective 4. Find nth roots. Find nth roots. Let's check it out. We check it square roots as x index is equals to 2. We check it understood about cube roots, which the index is equals to 3. And now we're gonna find out about other roots that have index n. It's going to be defined as this: is if a equals to b exponent n, the nth root of a equals b, right? If the index is even, the root is not you cannot have the nth root of a negative number if n is even. You remember the square root, right? You cannot have a square root of a negative number. It's not a real number. And you cannot have an nth root of any number, negative number, if the n is an even number, if n is an even number. Okay. But if n is the index n is odd, the number a can be negative or positive or 0. It doesn't matter. It's the same rule that you have seen for the cube roots. Okay, let's work some examples to understand. Find each root, and you can use your calculator, or you can work out by hand, calculate by hand. And first letter A, 6th root of 64, and I'm guessing it's going to be 2, but let's try here. Let's check and counting in your hands. 2 times 2, 4, times 2, 8, times 2, 16, times 2, 32, times 2, 64. So 64 is going to be equal to 2 exponent 6. That means this is equal to 2. Now check it out. Now we have a negative number here, but the index is an odd number, is 5. So 5th root of negative 32. Let's try here by hand. Negative 2 times negative 2, 4, positive 4, times negative 2, negative 8, times negative 2, positive 16, times negative 2, negative 32. That means square root, 5th root of negative 2 exponent 5, which is equal to negative 2. Okay. And check this out now, and we have 4th root of negative 16. But now the index is an even number, and this is the same situation of the square root of negative number. No real number solution. Okay, no real solution. You're not going to have a real number as solution for this radical. Okay, now working next objective, find nth root of a exponent n when a is a real number. If n is an even positive integer, then nth root of a exponent n is going to be the absolute value of a. So if it's a positive, okay. If n is an odd positive integer, then you're just gonna say that square root or nth root of a exponent n equals to a, because now you can have negative. If it's odd, you can have negative or positive numbers here as a solution and as the radicand. Checking the examples so we can understand. See this one, first one, a square root of negative 4 exponent 2. So remember the rule. Let's check here the rule. Is going to be absolute value of a, and a here is negative 4. Absolute value of negative 4 equals to 4. Okay, and next thing here that we have is 4th root of x minus 2 exponent 4. So this is the same thing as we have seen before on this rule. Now we have to apply the absolute value, because we don't know if the value of x, we don't know if this is going to be negative or positive, but the result of this can never be a negative. That means this is going to be absolute value of x minus 2. And now this, the 5th root of 2x minus 7, everything here exponent 5. And in this situation, check the rule here. We don't need to apply the absolute value because it's an odd index, right? The index here is odd. You're just gonna write 2x minus 7, because this number can be positive and also can be negative. And now again you have a square root, and if it's a square root, the result cannot be negative. And the square root of 5, we can find out here, is 5, right? The square root of 25 is 5. And we have to find now square root of x squared. And apply the rule, and you have to write down as an absolute value function. 5 times absolute value of x. Great, next objective, number 6, to graph square and cube root functions. Since every value of x that's substituted into the equation y equals nth root of x produces a unique value of y, the root relation actually represents a function. The domain of the root function, when the index is even, is all non-negative numbers. And the domain of the root function, when the index is odd, is all the set of real numbers. Let's check some, let's find first some values. If we have this function here, fx equals equals square root of x plus 2, and the other function gx equals cube root of x minus 1. Letter A, f for x equals 7, f7. So you just plug in here 7 plus 2, right? Instead of x, you substitute, you change for 7, square root of 9, so f7 equals 3. Next, f of x equals 0. So plug in 0, 0 plus 2, this is square root of 2, that means f0 equals square root of 2. What about, now we are using the g function, g of 9. So plug in 9 here, cube root of 9 minus 1. So g9 is going to be equal, 9 minus 1 is 8, cube root of 8 is 2. And the last example for this set here, g10, g for x equals 10. Plug in 10 minus 1, cube root, right? And 10 minus 1, 9. G10 equals cube root of 9, and that's it. And how to graph? First, let's graph this function, which is a square root. Okay, let's graph this square root. Let's try a few numbers here. We can start with 0 and 1, and we can use we can have 4, but we can use also 2 and 3, and you're gonna need your calculator. Let me find my calculator here now. My calculator, okay. If x equals 0, y equals 0. If x equals 1, square root of 1 is 1, y equals 1, right? What about if x equals 4? If x equals 4, square root of 4 is 2. And the square root of 2, let's calculate here, is 1.41. Let's use 2 decimals, 1.41. And what about square root of 3? Square root of 3, 1.73. Let's also, since we have our calculator here, let's find the square root of 7. Square root of 7 let me write down here 2.65. So 7, 2.65. Now we have a few points. We plot here on the graph. 1, 2, 3, 4, and this for 7 is 2.65. 7 is here, right? 5, 6, 7. 2.65 is somewhere here, and you can have the graph. It's like something like this. Something like this. Yeah, approximately this. Notice that the domain is going to be the non-negative numbers, and we can represent here as an interval notation. Actually, this is going to be brackets, because 0 is included, 0 is in, all the way to positive infinity. This is the domain for the square root function, because the negative numbers are not included. Now let's work here the graph of the cube root. Okay, and let's find here some numbers, and actually here we can work with negative. Let's work with negatives. Negative 8. The cube root of negative 8 is negative 2. And negative 1. Let's use the calculator to have more points. Let's use the calculator to find the cube root of negative 4, and type here 4 negative cube root. You're gonna use this exponent 3 inverted. This is cube root equals negative 1.59. Negative 1.59. And for negative 1, we're gonna have the cube root of negative 1 is negative 1. 0 is 0. 1 is going to be 1. And we can also have let's complete here x and y. We can also have 4, 1.59, and 8, 2. Okay, and let's apply. Let's go to the graph, and we have 0, 0 here. We have 1, 1 on both sides. 1, 1, negative 1, negative 1, and we're gonna have 4, negative 1.59. 1, 2, 3, 4 here. For let's plot this one. 4 and 1.59. 1.59 is somewhere here. And 8 and 2. 8 is going to be somewhere here. 8. Let's stretch 8 and 2 here. Okay. And we're gonna have the same thing on the negative side. 1, 2, 3, 4, negative 4, negative 4, negative 1.59 here, and negative 8. Negative 8 is going to be somewhere here. Negative 8 and 2. And let's connect the dots. Connect the points, and we're gonna have the graph of the function y equals cube root of x. And that's it. This is the end of section 7.1. Thank you for watching.